Lesson 76, using both substitution and elimination and negative vectors. All right, we have problems where we're going to have to use substitution and elimination to solve. We've used substitution and elimination before with two variable problems, okay, two equations with two unknowns. Now we're going to be working with three variable problems. All right, so we're going to be doing three equations with three unknowns. We're going to work through just a couple examples together, and then I'll have you do one on your own. There's not a whole lot of notes on this because they are two concepts that we have done before. All right. All right, so here's our first example. X equals 2y. X plus y plus z equals 9. X minus 3y minus 2z equals negative 8. All right, so these are the three equations we're going to be working with. Now, again, remember we're using substitution and elimination. In the first equation, we have x equals 2y. What I would suggest doing is working with an equation so that you're only left with x and y. All right, so we're going to try to eliminate the other variable that is here, and that would be the z's. All right, so in these two equations here, we want to eliminate the z's. I can do that by multiplying this first equation by 2. All right, so if I multiply everything through by 2, I get 2x plus 2y plus 2z equals 18. This allows my z's to be canceled out. I'm left with 3x minus y equals 10. Now that I've taken care of elimination, I've taken care of the z's, I can use x equals 2y to substitute in for x to solve for y in this equation. So in place of x, we're going to put 2y. And then we can solve this equation for y. All right, so 3 times 2y is 6y. 6y minus y is 5y. All right, so we have 5y equals 10, which means that y equals 2. All right, and of course, once we've solved for one variable, we can use substitution to solve for the others. All right, so if y is 2, we can use the equation x equals 2y, so that x is going to be equal to 4. And then we just need to choose another one of the equations. So I'm going to choose the second one, x plus y plus z. All right, so in place of x, we have 4. In place of y, we have 2. All right, and we are solving for z. All right, 4 plus 2 is 6. And 6 plus 3 gives me 9, so z is equal to 3. All right, instead of writing our answer as an ordered pair, we're going to write our answer as an ordered triple. So we're going to have our x, y, and z values. All right, so we have 4, 2, 3. All right, and that is the solution to our equation. 4, 2, 3. All right, let's try another one. Again, we'll work this one together. All right, we have 2x plus 2y minus z equals 12. 3x minus y plus 2z equals 21. And x minus 3z equals 0. All right, now that we have written the equation down, we want to, first of all, find one variable that's equal to something else. What I'm going to do is take this second equation, and I'm going to make it x equals 3z. So now at least I have one variable equal to something so that I can use that for substitution. The next thing I want to do is use one of the equations, one of the top two equations, to eliminate one of the variables. All right? Now, because this equation deals with x's and z's, I'm going to keep x's and z's in my equation, and I'm going to eliminate the y's up in these two equations, which means I need to multiply the second equation by 2. All right, so my first equation is going to stay the same, 2x plus 2y minus z equals 12. My second equation becomes 6x minus 2y plus 4z equals 42. Alright, so when I combine the terms, I get 8x, the y's are canceled out, plus 3z equals 54. From that point, I can substitute 3z in for x. Alright, so 8 times 3z plus 3z equals 54. 8 times 3z is 24z plus 3z equals 54. 24 plus 3, 27. And 54 divided by 27 gives me 2. Alright, so when I plug it into my equation, I get z equals 2. If I substitute that 2 back in for this equation here, x is going to be 6. And the last thing I need to do is substitute it into an equation above. Alright, so I'm going to use the first one again. 2 times 6 plus 2y minus z equals 12. So I have 12 plus 2y minus 2 equals 12. If I combine like terms, I'm left with 2y plus 10 equals 12. Subtract 10 from both sides, 2y equals 2, which means that y equals 1. And again, we write our answer as a triple, ordered triple, so we're going to have 6, 1, 2. X is 6, y is 1, and z is 2. Alright, hopefully using those two examples and basing these problems off your previous knowledge, you'll be able to handle this third example no problem. Alright, so this example, I want you to go ahead and jot down in your notes, x equals 3y, x plus y plus z equals 56, x minus 2y minus 3z equals negative 25. Go ahead and take a minute to jot that down. I do want you to come back and work this problem out so that when we check it in class you'll have it. But we also need to talk about negative vectors in this lesson. Alright, so go ahead and jot this down. If you need to, go ahead and pause the video. When you're done writing it down, hit play and we'll talk about negative vectors. Alright, the second part of this lesson is talking about negative vectors. Now, we have talked about vectors as far as polar coordinates and rectangular coordinates and changing between the two. We've talked about what happens when we have negative angles. In this lesson, we're talking about negative vectors. So this is the number before our little angle symbol. What happens when those numbers are negative? Alright, so there are 5 steps in solving for negative vectors. And the first step is what ends up being a little bit different. Alright, so let's talk about the steps first, and then we'll go back and look at examples with these steps. So step 1 is to draw out the vectors. The second step, to label the parts. Step 3, find the angles. Step 4, find the added vectors. All right, so we're talking about vector addition again. And finally, step 5 is to solve for R and U. Okay, so we're going to draw our vectors, label all of the parts in our diagrams, solve for the angles, solve for the added vectors, and finally combine R and U values to get a final answer. All right, I'm going to leave those steps, and we're going to work out one of these examples. All right, I want you to pay close attention because we are going to do this one together. This next one I'm going to leave you to do on your own. And we're only going to do one together because it's very similar to things that we have already talked about. There's just one change. All right, so we are adding, we've got -4 with an angle of -20. plus 5 with an angle of 135. Now, notice in the first, we've got a negative vector length, which we haven't seen before. We've also got a negative angle. All right, so let's talk about that one first. The first thing we want to do is draw out the vector. All right, we're going to start drawing just as normal. We have our coordinate plane. Now, our negative angle, we recall, starts at the positive x-axis, but because it's negative, we're moving clockwise instead of counterclockwise. All right, so negative 20 is going to be right there. All right, so my vector, normally we would call our angle 20 and we would call our vector here 4. But because it's a negative vector, it's actually going to reverse itself. So this becomes my true vector. So instead of my vector being in quadrant 4, it's actually negative, so it's going to be reversed back up into quadrant 2. All right, so the only thing that we need to remember about negative vectors is that once we find our angle, if our vector is negative, we do it in the opposite quadrant. We do it catty corner from where it should be. All right, our angle is still going to be a 20-degree angle. All right, and we still have our sides labeled R and U. We don't go about finding R and U any differently. The only thing that is different in this lesson is that our vector is reversed when it's negative. All right, so we've drawn out that vector. We've labeled the parts. Let's draw this one over here. This one is normal. We've got a positive angle with a positive vector. All right, 135 degrees would be somewhere right in here. Our vector length is 5. All right, because 135 is outside the triangle, the angle inside of my triangle is going to be 180 minus 135. All right, so our angle is actually going to be a 45-degree angle. And again, we need to solve for R and for U. All right, so we've drawn out the vectors. We've labeled all of our parts. Now we need to go about finding, we found all of the angles. All right, now we just need to find our vectors. All right, so we're looking for our R's and U's. All right, so in this first one here, we're doing the sine of 20 to find U, which is the opposite over the hypotenuse. All right, so when we plug that into our calculator, U is going to be 1.37. To solve for R, we use the cosine function. So the cosine of 20 is going to be the adjacent over the hypotenuse, which means that our R value is going to be 3.76 when we plug it into our calculator. All right, we'll come back to those in just a minute. Let's talk about our second one. All right, again, we're going to use the sine function to find U. So we have the sine of 45 is U over 5. All right, if we plug that into our calculator, 5 times the sine of 45, U is going to be 3.54. All right, then we're going to use the cosine function to find side R. So we have the cosine of 45 equals R over 5. All right, and in order to solve for R, we do 5 times the cosine of 45, and that will give us 1.71. All right, now we need to talk about adding our vectors, okay? Remember, R comes before U, okay? We do it alphabetical order. So let's start with our R values first. Our first R value is 3.76, but keep in mind that it is negative because it's on the negative axis. All right, so we have negative 3.76. And we're adding that to negative 1.71. All right, again, that R value is on the negative axis. All right, so if we add those together, our new R value is going to be, hang on one second, my notes just confused me. Okay, going back, this R value is not 1.71. 5 times the cosine of 45 is actually 3.54, same as our U value. All right, so when we come back to add our vectors, we're going to be doing plus 3.54. All right, that'll make a little more sense for those of you who were confused by that. All right, so when we combine our R values, we're going to get negative 7.3 R. All right, so that is our new R value. Now we need to combine the U's. All right, in my first equation, I have 1.37 U. Now, because it is going up, it's positive. All right, so it's on the positive y-axis, so we have 1.37 U. And over on this side, again, the u value is positive, so it's plus 3.54u. When we add these, our new u value is going to be 4.91u. And there we have added our vectors. All right, so keep in mind the only thing that's different is when we have a negative vector, all right, we need to make sure that we reverse our vector length into the opposite quadrant. That is the only change. All right, so keeping in mind that change, this example is one that I would like for you to do on your own. All right, we have -2 with an angle of -15 degrees, plus 5 with an angle of 110 degrees. All right, so I want you to go ahead and try that one on your own. Work it out, and we will come back and we'll check it in class.